1.3 Formation of ions. We learned that atoms can gain or lose charges to form charged particles called ions. The reason why they would want to do this is because of something called the octet rule. The octet rule is the generalization that states when ions combine, they tend to achieve 8 electrons. If we look at noble gases on the periodic table, such as helium, neon, and argon, we'll notice that they have 8 electrons in their outermost shell. This means that they're very stable. If an atom has 8 electrons in their outermost shell, then they will not have a tendency to try to gain or lose any electrons. If we look at the first element in this group, we notice that it only has 2 electrons in its outermost shell. Given that this is the first shell around the nucleus, this is in fact the maximum number of electrons that can be held in this energy level. So for the first element of the noble gases, 2 is the maximum number, and they don't have a tendency to gain or lose electrons. In every other element of the noble gases, their outer shell contains 8, which is also the maximum number of electrons that can be supported. An electron arrangement called a full or stable octet is one in which the valence shell has 8 valence electrons. Remember that for hydrogen and helium, this is only 2 because that's the maximum number of electrons that can be held in the first energy level. An ion is a charged entity formed when an atom gains or loses 1 or more electrons. Keep this in mind. This is the subatomic particle that is gained or lost in the formation of an ion, the electron. It's not the proton, it's not the neutron. Let's look at the formation of positively charged ions. Positively charged ions are called cations. And the way you can remember this is by writing out Ca+. This plus, which kind of looks like the T in the word cations, will remind you that cations are positively charged. A cation is defined as a positively charged ion formed by the removal of 1 or more electrons from the valence shell of a neutral atom. Here we have a sodium atom. A sodium atom has 1 electron in its outermost shell. And remember that atoms want to try to achieve an octet or a stable outer shell, 8 electrons or 2 in the case of hydrogen or helium. So in order for sodium to become stable, it would either have to gain 7 electrons, which is not an easy task, or just lose this outer electron. If it loses this outer electron, then what will remain is a full shell or energy level underneath it, a stable octet. And this is, in fact, what happens. So a sodium atom, with the help of energy, will lose 1 of its electrons and form a sodium ion. Since it lost 1 negative charge, its overall charge will now no longer be neutral. It will, in fact, be positive. And we can do inventory with this. If we look at the sodium atom, we can see that it has 11 protons, 12 neutrons, and now 10 electrons. Let's do an inventory. If we have 11 positive charges and 10 negative charges, we are going to be left with an overall charge of +1. Also note that ions are denoted in square brackets where the overall charge of the atom or group of atoms is indicated as a superscript at the top right-hand corner of the rightmost square bracket. Now this overall charge can be called the atom's valence. Valence is the charge on an ion, the combining capacity of an atom determined by the number of electrons it will lose, add, or share when it reacts with other atoms. So sodium has a valence of +1. Let's look at negative ions. Negative ions are called anions. And the way we remember this is these first two letters, a negative ion. We'll look at the formation of an anion from chlorine. Let's start by looking at the number of electrons in the outermost shell or valence shell of a chlorine atom. If you notice, chlorine has 7 valence electrons. In order to achieve a stable outer shell, it would have to gain just 1 electron. And that's not a difficult task, and it's something that chlorine does very well. So chlorine will gain an electron, and now in its outermost shell, it will become stable because it has 8 electrons. Since it has gained an additional negative charge, we call this an ion. We have square brackets around the model of the atom, and at the top right-hand corner, we have the valence or the charge of the atom. In this case, since we have 17 protons and 18 electrons, we end up with an overall charge of -1. And this overall charge of -1 is denoted as a subscript at the top of the model of the ion. So we say that chlorine has a valence of -1. Now, some periodic tables will actually tell you right on them what the valence of the atom is. For example, sodium has a valence of +1, just like we showed in our diagram up above, and chlorine has a valence of -1. So this top right-hand corner will show you the valence of these atoms. Now, if you notice, some atoms have multiple valences, like chromium, iron, copper. These are called multivalent atoms. A multivalent atom is a property of having more than one possible valence. So we have a list of multivalent atoms. We have copper that can form a valence of +1 or +2. Iron that can form a valence of +2 or +3. This valent chart, multivalent chart, is something that you will find on a reference sheet. You won't have to memorize it, but you'll have to use it and access it, and it will be given to you on every test, quiz, or final exam that you write. Now, I also want to talk about polyatomic ions. Poly meaning many, and atomic meaning atoms. So this is an ion made up of more than one atom that acts as a single identity. For example, the nitrate ion. The nitrate ion is made up of the elements nitrogen and oxygen. There's 1 nitrogen and 3 oxygens, and it has an overall charge of -1. Here is a list of polyatomic ions with their official name and their overall charge. For example, we have the acetate ion with an overall valence of -1. Bromate, valence -1. Chromate, valence of -2. This table is another table that you will have to access and use throughout this course, and one that will be given to you on a reference sheet that can be used for every test, quiz, and final exam. Ions play a special part in the human body. 99% of your body is made up of 6 elements, and in order of abundance by mass, they are oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. Your body also contains much smaller quantities of sulfur, chlorine, sodium, magnesium, iron, and iodine, many of which exist as ions in dissolved water. And some of these ions play a key role in our body. For example, sodium is important for body fluid control. We get sodium from salt, cheese, and other preservatives in food. Potassium ion is important for body fluid control and cell functions. We get potassium ions from bananas, milk, potatoes, and other dietary means. Calcium ions are a key component of bone and teeth, found in milk, cheese, and spinach. Iron ions are important in muscle function, an essential part of hemoglobin in blood. We find these in kidney beans, asparagus, pine nuts, and other dietary means. Magnesium ions are crucial for muscle and nerve functions. We find magnesium in green plants, nuts, and grains. Chlorine is important for body fluid control. Chlorine is found in table salt. Iodine ions is found in fish, dairy products, and iodized salt, and it helps regulate the body's metabolism. Please try any homework problems that were assigned, as well as any LMS quizzes that you need to complete.